Autonomous coding ability. Large language models like GPT-5.5 and Claude Opus 4.8 are designed to act as autonomous coding assistants that can plan and execute multi-step programming tasks. OpenAI describes GPT-5.5 as able to excel at writing and debugging code, moving across tools until a task is finished. In practical terms, GPT-5.5 can take a vague, multi-part software request and handle the details itself, from breaking the problem into steps to writing code, running tests, and iterating on failures. Early testing reports indicate that GPT-5.5 can hold context across large codebases and reason through ambiguous failures, checking its work with tools as it goes. In other words, for well-scoped development tasks, think moderate-sized features or fixes, GPT-5.5 often requires very little hand-holding. Anthropic's Claude Opus 4.8 is pitched as a more effective collaborator for coding projects. Anthropic's previews note that 4.8 outperforms its own earlier models on coding benchmarks. In one internal evaluation, Claude 4.8 scored 69.2% on a software engineering task SWE Bench Pro, surpassing GPT 5.5's reported 58.6%. On simpler command-line workflows, GPT 5.5 still leads, but Claude's strength is clear on tasks involving complex, multi-file changes. Early users have reported that Claude 4.8 is very self-checking. It asks the right questions before making complex changes, finds its own mistakes, and pushes back when a plan isn't sound. In other words, Claude's update focuses on being careful and deliberate. In practice, this means Claude may halt or ask for clarification if a developer's instructions are unclear, whereas GPT 5.5 might keep pressing ahead. Bottom line, GPT 5.5 appears superb for well-defined, sequential coding tasks where the steps are clear and test feedback is straightforward. Claude Opus 4.8, by contrast, shines when the work is more open-ended or ambiguous. It will methodically guard against logic mistakes and unnecessary code churn. For example, benchmarks and expert commentary suggest using GPT 5.5 for high-volume automation or CLI-heavy pipelines, and reserving Claude Opus 4.x for deep codebase issues and refactoring, where resilience matters. Repository understanding. A key challenge for coding agents is grasping a large codebase. GPT 5.5 and Claude 4.8 both support very large context windows, meaning they can consider hundreds of thousands of lines of code at once. In fact, OpenAI says GPT 5.5 has roughly a 1,050,000 token maximum context, about 750,000 words, far beyond GPT-4's 128K. Similarly, Claude 4.8 supports up to 1 million tokens of context. In practical terms, each model can load most medium-sized repositories or entire modules into memory and reason about them. However, having a large context window is not a cure-all. When debugging or refactoring, dumping an entire 200K line project into the model often backfires. The assistant gets overwhelmed. Researchers suggest a targeted approach. For instance, one workflow study advises first reproducing the bug and capturing the stack trace, then feeding only the relevant files in that trace to the AI rather than everything. This kind of context scoping was shown to dramatically improve success rates. First attempt fixes jumping from under 40% to 70 to 85%. In short, both GPT 5.5 and Claude 4.8 can see entire projects, but in practice, it's often smarter to curate the context. Tools like code indexers or simple dependency analysis can automate feeding only the needed files to the model. In terms of architectural reasoning and style, neither model inherently ensures consistency with your project's existing patterns. They rely on general coding conventions learned during training. Anecdotally, developers find that both models do a decent job emulating the surrounding code style if prompted explicitly, but you still need to review their changes. Claude's honesty tuning may make it more likely to flag when it's unsure, potentially preserving structure better. Tool use and agent behavior. GPT 5.5 and Claude 4.8 are purpose-built for use in AI-powered agents that can interact with the development environment. For example, GPT 5.5 can be accessed via OpenAI's Codex API or through AWS Bedrock. Amazon notes that the latest OpenAI models, including GPT 5.5, will be available in preview on Amazon Bedrock, allowing teams to use them with familiar security and cost controls. Bedrock even offers managed agents that let you build production-ready AI assistants using GPT models. In practice, this means you can grant GPT 5.5 access to your code repository, a terminal, or other tools like web search or API calls, and it will operate in that environment. GPT 5.5's announcement explicitly touts its ability to plan, use tools, check its work, and keep going on a messy multi-part task. Claude Opus 4.8 similarly powers Anthropic's coding agent products like Claude Code and can be integrated into dev pipelines. Anthropic introduced a dynamic workflows feature for Claude that lets the model spawn hundreds of parallel subagents in one session. For example, handling a large-scale migration or a complex refactor and then verifying the results. Claude Code is explicitly designed for multi-file editing. Anthropic's marketing says, work with Claude directly in your codebase. Build, debug, and ship from your terminal, IDE, Slack, or the web. Describe what you need, and Claude handles the rest. In effect, both GPT 5.5 and Claude 4.8 act like flexible teammates that can call compilers, run tests, make Git commits, or look up documentation as directed. Practical integration. If you're building a coding agent app, you'll generally hook these models into workflows via APIs. GPT 5.5's launch includes native support for code interpreter tools and function calling, and it can even process images, e.g., passing screenshots of a UI or CI log directly into the prompt. Claude 4.8 also supports tool calls and has been tested on real-world CI flows. Both platforms let you adjust how deep thinking the model does. Claude's new effort control slider can trade off speed versus thoroughness, and Bedrock-managed GPT agents can be tuned similarly. Debugging and test repair. Real-world engineering tasks always involve failures, broken tests, crash logs, flaky behavior. Here again, GPT 5.5 and Claude 4.8 show different strengths. GPT 5.5 is explicitly trained to interpret errors and fix code. OpenAI notes it can handle debugging, testing, and validation tasks in Codex, and that it is better at reasoning through ambiguous failures than earlier models. In practice, this means GPT 5.5 can often take a failing test or compiler error as input and suggest a concrete fix with little additional prompting. It tends to provide concise explanations and stabilize in patches quickly. Early reports suggest it can explain which line is causing the error and propose an immediate fix with accompanying regression tests. Claude Opus 4.8 was also built for debugging work, but the emphasis is on systematic reasoning. In debugging scenarios, testers found Claude tends to methodically trace through the code dependencies. One comparison noted that with sufficient context, Claude generated multiple test cases and robust solutions, most robust and safe, for edge cases. Another praised Claude for outlining improvements like more efficient algorithms rather than just brute fixes. Importantly, Claude's training felt it should question ambiguous instructions. As quoted earlier, it will push back on an unsound plan and double-check assumptions, which helps catch hidden bugs. Workflow tip. In either case, debugging works best when you feed the model structured information. For example, experts recommend always including the full error message with stack trace, the reproduction steps, and the expected versus actual behavior in your prompt. Providing that upfront context lets the model focus on the right code. In one study, following this disciplined approach boosted fix rates from about 30% to 70 to 85%. Code quality and maintainability. When it comes to the style, efficiency, and safety of generated code, both models strive to follow best practices, but researchers have noted subtle differences. GPT 5.5 tends to produce lean and efficient code. Newer tests show GPT 5.5 can complete a coding task using roughly 40% fewer tokens than GPT 5.4 did. In practical terms, this means GPT 5.5 often writes more concise solutions, fewer unnecessary comments or boilerplate, for the same functionality. This token efficiency also translates to roughly a 20% lower total token usage in real-world tasks. Concise code can be easier to read, but it also means GPT 5.5 is less likely to over-engineer a simple function. However, more minimal code sometimes means less built-in error handling or testing unless you explicitly ask for it. Claude Opus 4.8, on the other hand, is known for generating robust, practice-oriented code. Evaluations have found that Claude and similar models often suggest encapsulation, validation, and thorough test cases in its answers. For example, one comparison showed Claude expanding a function to include clear variable names, docstrings, and boundary checks, essentially refactoring the snippet into a more maintainable form. Another test showed Claude optimizing a prime checking function to skip unnecessary loops, greatly improving its performance on large inputs. In short, Claude's outputs tend to emphasize correctness and structure, even if that means being a bit more verbose in code or explanation. Claude also has strong safeguards to avoid hallucinated code, e.g. inventing imaginary APIs, which can improve security by not producing undocumented behavior. Neither model is guaranteed perfect. After generation, you should still run linters, security scans, and code reviews. But as a rule of thumb, GPT 5.5's code will be generally minimal and to the point, so you should check it covers edge cases. While Claude's code often looks like it came from an experienced engineer following design guidelines, so you might streamline it if brevity is important. Instruction following and constraints. A key requirement in software tasks is that the AI only makes exactly the changes you asked for. Both models have been tuned to respect developer instructions. GPT 5.5 was specifically trained on long horizon tasks so that it understands task intent over many steps and shows fewer mid-task direction changes. This means you can give it a strict set of requirements, e.g., add exactly these two fields to this class and nothing else. And GPT 5.5 is less likely than older models to wander off or add extra features. Claude 4.8 also emphasizes strict compliance. In safety tests, Anthropic notes that Opus 4.8 is more pro-social. It respects user autonomy and aligns with the user's interest. It also explicitly flags uncertainty rather than guessing. In the context of coding, this means if Claude 4.8 is unsure about an instruction, it's more likely to ask for clarification or say, "I don't know," rather than blindly change unrelated code. Again, practical lab reports agree. Claude will often respond with questions or caveats if the developer's request is vague. In practice, neither model will knowingly violate fundamental rules, like don't change anything outside the specified function. But because GPT models can occasionally invent placeholders, like to-do comments, if asked to skip code, one should verify the output. Claude's conservatism in sticking to instructions can be an asset here. For critical projects, it may help to run a secondary check, e.g., a second pass with the other model or automated tests, to ensure no unintended changes slip through. Long horizon task completion. Real-world software projects often span many steps. Design a feature, implement it, test it, refactor, and repeat. GPT 5.5 and Claude 4.8 were both designed with long tasks in mind, but they approach them differently. GPT 5.5 has improved persistence. OpenAI's tests show it's solving complex GitHub issues end-to-end more often than before. Its large context and better planning mean it is more likely to carry through a chain of development steps without losing track. For example, GPT 5.5 can handle a 20-hour human-level coding task like implementing a new service in a single go more effectively than GPT 5.4. Claude 4.8, meanwhile, explicitly supports asynchronous multi-step workflows. Its dynamic workflows feature lets it spawn internal subagents and verify results, effectively managing very long processes. In other words, Claude can plan out and execute hundreds of small tasks in parallel within one session, useful for projects like migrating an entire codebase. It also offers high-effort modes with tunable depth, so it can be made to deliberate as needed. Practically, this means if your task involves lots of back and forth, e.g., generate code, run tests, fix failures, repeat. Both models can handle it, but Claude provides more built-in structure to do so. GPT 5.5 will carry on if you keep prompting it, while Claude can autonomously leap with its workflow engine. Front-end, back-end, DevOps, and AI app coding. In terms of specific domains, both GPT 5.5 and Claude 4.8 have broad capability across modern tech stacks. Front-end, React, Next.js, TypeScript, etc. on typical UI tasks, creating components, styling, wiring user events. Both models perform similarly well. In a head-to-head GPT-4 Claude test, researchers found for writing a standard React component or REST endpoint, both models produce equivalent quality. GPT 5.5's new vision capabilities even allow it to reason about UI screenshots directly, which can help with debugging CSS or layout issues. Backend, Python, Node.js, JavaScript, database logic, APIs. Neither model is specifically tuned to one language, so both can generate and understand code in Python, JS, Java, etc. GPT 5.5 benefits from extremely large training data. OpenAI notes it saw more code corpora than GPT-4, so it usually just works for most backend queries and quickly writes API calls or SQL queries. Claude 4.8's strengths emerge on complex backend problems. In situations like refactoring an entire service or reasoning about database schema interactions, Claude's careful, multi-step approach tends to produce more consistent and correct solutions. DevOps infrastructure, cloud scripts, CI/CD. Both models can write and fix automation scripts, Docker files, CI configs, Terraform, etc. GPT 5.5's multimodal abilities let it process system logs or network diagrams, which could help in diagnosing build errors. Claude Code's large context is useful when dealing with long YAML files or complex dependency graphs. Hands-on experience suggests that on straightforward DevOps tasks, like writing a new CI step, GPT 5.5 often completes them quickly. For more involved infrastructure changes, e.g. migrating a microservices deployment, Claude's planner-like behavior may suggest safer step-by-step edits. AI app integration. Calling other AI services, model orchestration. Interestingly, GPT 5.5 is built by OpenAI and is naturally geared to integrate with other OpenAI tools. It can call OpenAI functions and APIs easily. Claude 4.8 likewise is often used with its own Claude tools, like LangChain for Anthropic. In either case, both can update code to include AI API calls. Neither has a clear edge here. It depends on which ecosystem you prefer. In summary, neither model is limited to one technology area. They both can handle front-end, back-end, DevOps, and AI agent code. The difference is again in approach. GPT 5.5 will act as a speedy generalist helper, filling in common patterns across many languages quickly, while Claude 4.8 will excel where tasks require more cross-file consistency and complex reasoning. Cost, latency, and deployment practicalities. From a product perspective, cost and performance are crucial. GPT 5.5 comes at a premium price. OpenAI's API charges $5 per million input tokens and $30 per million output tokens, while Claude 4.8 is $5 plus $25 for the same volumes. In effect, GPT 5.5's output tokens cost about 20% more. OpenAI explicitly calls this pricing a capability bet, not a price cut. It's roughly double GPT 5.4's rates. The good news is that GPT 5.5 is roughly 20% more efficient in practice due to needing fewer tokens, so the net cost per completed task only rises by a modest fraction. Latency. In deployment, GPT 5.5 has been engineered to perform as fast as its predecessor in real use. OpenAI notes that GPT 5.5 matches GPT 5.4 per token latency, despite its greater complexity. Claude 4.8 is also tuned for speed. It offers a fast mode that runs at 2.5 times the normal speed, which Anthropic made 3 times cheaper to use. In other words, if low latency is critical, you can use Claude's fast setting or keep GPT in shorter turn interactions. Reliability and availability. Both models are offered via managed cloud APIs. OpenAI's API Azure Bedrock for GPT Anthropic's API AWS for Claude. As of mid-2026, GPT-5.5 is rolling out in ChatGPT's Plus Enterprise tiers and via the OpenAI API. Claude Opus 4.8 is accessible through Anthropic's platform. In practice, they each enjoy the uptime and scaling of big vendors. One practical difference. Wired Italy reported that Claude 4.8 kept the same pricing structure as its predecessor. So teams using Claude won't see a price hike, whereas GPT 5.5's costs jumped. Context management costs. Keep in mind that hitting the full context window costs extra tokens. GPT 5.5 allows up to 1.05 million tokens, so you can feed entire repos, but every token costs. Sampling out unused context or archiving old chat turns can save money. Claude Codes also charges per token, but at slightly lower rates. Evaluate which model gets you better ROI on your tasks. If Claude solves a tough problem in one pass, saving developer hours, that can offset GPT's higher token price. Best use cases when to use GPT 5.5. Choose GPT 5.5 as the first try for well-defined procedural tasks and high-throughput automation. For example, if you are building an automated code generator for standard features, API skeletons, data validations, typical algorithm implementations, GPT 5.5's broad knowledge and efficiency make it ideal. It also thrives in productivity tools. Chat-based coding assistants and Copilot-like scenarios will benefit from GPT 5.5's fast, concise answers. Use it in command line or CI/CD agents that run many small changes in parallel. Its terminal bench score is higher. AI OPA. Its multimodal abilities mean it can help integrate visual inputs, like GUI snapshots, into debugging flows. When to use Claude Opus 4.8. Reach for Claude 4.8 on the hard, complex tasks. This includes large-scale refactors, deep architectural changes, or any scenario where the stakes are high. For instance, if your team needs to merge and update hundreds of modules and maintain cross-cutting invariants, or to zero in on a tricky cross-file bug, Claude's methodical approach is advantageous. It's also a strong choice if you have a tight budget for human review, because Claude's extra consistency can reduce the need for repeated corrections. Claude 4.8's honesty improvements make it safer for code that must follow strict rules or regulations, since it will more readily admit uncertainty rather than guess. In agentic pipelines, one might use GPT 5.5 to generate a bulk of code, and then pipe its output into Claude 4.8 as a quality gate to check and refactor it, leveraging each model's strength. Hybrid workflow. Many teams will find a hybrid approach works best. For instance, a CI agent could run GPT 5.5 on each new commit to suggest quick fixes and run tests, and simultaneously have Claude 4.8 monitor larger integration sweeps or handle issues flagged as hard. One concrete strategy. Use GPT 5.5 as the default code writing engine, especially on new, greenfield code, but validate its output with Claude on every pull request affecting multiple files. This way, you get the speed of GPT with the care of Claude. Regardless of choice, remember that these models are tools, not replacements for architects or engineers. They perform best when prompted correctly and supervised by humans. The better model depends on your workflow design and priorities. As one analysis puts it, GPT 5.5 leads on well-scoped automation, knowledge work, and computer use, while Claude is allotted for complex, ambiguous codebase work, where error recovery matters. In practice, pick the model to match your task profile and toolchain. Conclusion: GPT 5.5 and Claude Opus 4.8 are both extremely capable coding assistants, but they are optimized for slightly different quarters of software development. GPT 5.5 is the best pick when you want a hard-working automator that can churn through well-defined batches of code quickly. Claude 4.8 is the right choice when you need a cautious collaborator for deep, tricky engineering problems. The technical founder or team leader should consider the nature of their workflow. Do you need speed and high throughput, or depth and reliability? There is no one-size-fits-all winner. In many AI-powered dev projects, you'll use both. Let GPT 5.5 handle the boring work and use Claude 4.8 where precision is critical. To get started, pick a simple self-contained development task. For example, add this new feature to our service and make sure all tests pass. Try running it end-to-end with GPT 5.5 via the OpenAI API or ChatGPT, and with Claude 4.8. Observe how each model approaches the problem. The next step might be to integrate the chosen model into your build pipeline or IDE using existing frameworks like LangChain, Bedrock Managed Agents, or Claude Code SDK. For a practical first move, sign up for the appropriate APIs, or ChatGPT Plus Enterprise for GPT 5.5 and Anthropic's Developer Access for Claude. And experiment with a pilot workflow. See which model is easiest to prompt for your scenario. From there, gradually expand. Add tools, code execution, search, scale to larger code bases, and build an agent that can iterate automatically. The key takeaway is to measure. Track how many tasks the model completes successfully and how much manual correction is needed. Over time, you'll refine where GPT 5.5 shines and where Claude 4.8 should take over, creating a powerful, hybrid AI coding agent tailored to your products. All links to sources are available in the text version of this article. You can find the full article at easycoding.tools/blog. Thanks for listening. For more practical AI coding guides, tool comparisons, and resources for builders, visit easycoding.tools. And if it's easier to remember, just go to aibuilds.it. It redirects to easycoding.tools.